This micro-credential addresses compression concepts in small engines and consists of 4 targeted skills. This targeted skill deals with troubleshooting compression problems within the valve system. Compression problems can result from part failures from the power development system or the valve system. Regarding valve problems, there are several different styles of valve arrangements. Older engines use an L-head design where the valves are alongside and parallel to the cylinder and are contained in the block. To remove the valves in an L-head design, first remove the springs and keepers using a special tool called a valve spring compressor. There are several different designs of valve spring compressors, but they all function the same way. The tool is placed between the spring and keeper. When the tool is closed, it compresses the spring and removes the tension from the keeper. The keeper can now be rolled around and removed from the valve stem. Pull the valve up and out of the engine. With the valve removed, it is possible to remove the springs. Now, newer engines use an overhead design where the valves are over top of the piston, but contained in the cylinder head. In this design, the action is the same, but the springs are not as strong as the L head and can be removed by hand. Simply push down on the valve spring and remove the keeper. Remove the spring, the valve will pull out of the head easily. Remember to mark all parts belonging to each valve. Lifters, push rods, rocker arms, valves, springs, and keepers need to be kept together for each valve. Clean all parts to remove the carbon deposits and oil. Any leftover gunk will affect accurate measurements. Valve faces are ground to a 30 or 45 degree angle. When valves close, they sit down on a ring of metal called a valve seat. This ring is cast into the block and is not removable, but it is repairable. When the valves close, they are supposed to seal. If the valve face or valve seat wear into a curved surface, the valves will leak compression. The valve face can be reground to the correct angle at an automotive machine shop. If the face is too worn, the valve will have to be replaced. Valve seats can be restored in-house with the right tool. If that tool is unavailable, then automotive machine shops can grind the valve seats. Valve faces and valve seats should also be checked for pits or cracks. The tool for restoring valve seats is a New-Way seat cutter kit. It is expensive, so not all shops can afford to purchase this tool. The kit contains pilot that slide down into the valve guides. There are metric and US standard sizes. The cutter head slides down over the pilot and has 2 angles. 31 degrees for 30-degree valve faces and 46 degrees for the 45-degree valve faces on the other side. Turn the cutter clockwise by hand, applying slight downward pressure. Cut the valve seats ½ degree to 1½ degree different. If the angles are cut differently, will the valve seal when it closes? Yes, because when both parts heat up, they will expand. By grinding them slightly different, that allows the valve to close, seal, but not stick or bind. Next, the valve guides and valve stems are inspected. Use a small hole gauge and a micrometer to measure the guides. Just a micrometer is needed for the valve stems. Hold the small hole gauge straight or the measurements will not be accurate. Measure several places along the hole, top, middle, and bottom. The same is true for the measurements along the valve stems taken in several places. Compare the measurements from the valve stem to the measurements from the valve guide. Check the manufacturer specs for acceptable or reject sizes. Usually, a difference of 0.02 is considered passable. Anything more than that is not acceptable. The compressor is needed to reassemble the valves, springs, and keepers in the L-head design. Insert the spring and keeper into the tool with the offset hole on the top. Use the compressor to squeeze both the spring and keeper. Place the compressed spring and keeper into the opening. Slide the valve down through the guide and through the offset hole in the keeper. Now push down on the keeper so that it locks onto the valve stem. Open the compressor to allow the spring to expand and pull the compressor out quickly. The spring and keeper should stay attached to the valve. Roll the engine around several revolutions to ensure that all parts are assembled and working correctly. The procedure is the same for overhead valves except that a valve spring compressor is not needed. The springs and keeper can be manipulated with fingers. The last task is to check and set valve clearances. There needs to be a space between the valve stem and tappet in the L-head version. Valve clearance on an overhead design is between the valve stem and rocker arm. Be sure to consult the manufacturer specifications for each engine being repaired. Using a feeler gauge, check the gap for each valve. The measurement is correct when the leaf fits snugly. The engine will have to be rotated until the piston is about 1/4 inch after top dead center, also known as ATDC. At this point, any compression release device will be disengaged. The only way to reduce the clearances on an L-head is to grind the valve face or the valve seat, or both. Removal of metal from those surfaces allows the valve to sit lower, thus reducing the gap. If grinding won't obtain the correct clearance, the valve should be replaced. Sometimes the machining reduces the clearance to nothing. When this happens, the valve stem will have to be ground shorter to achieve the correct gap. Valve clearances on an overhead valve design are much easier to adjust. There are screws used to adjust the gap. Remember to rotate the piston to the correct spot, 1/4 inch ATDC. This location is still important in the overhead valve design. Understand that compression is very important to starting and running a small engine. When dealing with compression problems, there are 2 ways to check it. The one addressed in this targeted skill was the valve system.